Welcome to Algebra 2. Go ahead, open your books. I highly recommend you open your books. I'm not good at drawing these graphs. It's better if you see it and understand it more. Again, it's on page 623. We're going to go ahead and get started. This is a review of graphing parabolas. I do have the steps over here, but we've done this before. You find the vertex, find that h is equal to negative b over 2a. Then you solve for y. That's going to be your vertex point. Then you're going to find your y-intercept, which is 0, comma, c. C is considered your constant, so it's that last number here. It's going to be 0, comma, c. Third thing is you find your roots. You can factor it, and if there's not factoring, I'll show you a different way in example 4. And then when you have inequalities, you have less than or equal to or less than or greater than. If you don't have the line underneath, it's dotted. If you have the line underneath, it's solid. If you have it as a greater than, you shade above the line, but in this case, since we're dealing with parabolas, you shade on the outside of the parabola. And if you have a less than symbol, you shade below the line or you shade inside the parabola. So it's slightly different from a regular graph. Example 1, we're going to go ahead and graph it, and then we're going to see how it looks from the graph there. First thing we do, we go ahead and we find the vertex. We treat it as y is equal to negative 2x squared plus 12x minus 16. Keep in mind, the negative sign, whenever it's in front of the x squared, that indicates an upside down parabola. So now, let's go ahead and find the vertex. Vertex is equal to x is equal to, bring it up here, negative b. B is considered 12. Divided by 2 times a. A is considered negative 2. If I do that, I get negative 12 over negative 4, and x is equal to 3. Next thing I do, I go ahead and find y. So since I found x, I go ahead and plug it into the equation. I make an equal sign for now. I'm not going to focus until the very end for the inequality. So y is equal to negative 2 times 3 squared plus 12x or 3 minus 16. When I do that, I get negative 2 times 9 plus 36 minus 16, and y is equal to 2. That means my vertex is considered 3, comma 2. And I'm not going to have it up here. I'm going to have it on my grid here. So 3, comma 2 is that point right there. That's my vertex, meaning it's my minimum and my maximum point of my grid. Next thing I do, I go ahead and solve for my y-intercept. My y-intercept was 0, comma c. Your c is considered your constant. Your constant is your last number there. So that means it's going to be 0. It's always going to be 0 first. And then your last one, which is negative 16. So when I graph that, 0, negative 16, that means that line hits the y-axis at negative 16 all the way down there. The third thing, finding roots. So you go ahead and you graph it. So let's say we have negative 2x squared plus 12x minus 16 equals 0. We can factor out a negative 2. We get x squared minus 6x plus 8 equals 0. And when we factor that out, we get negative 4 and negative 2. And now we set each of them equal to 0. Negative 2 equals 0 is false. X minus 4 equals 0. This is going to give you x equals 4. X minus 2 equals 0. Move the 2 over. You get x is equal to positive 2. So that means your two roots, that means that graph is going to hit the x-axis at 4 and 2. So when I have here, I have this being the vertex. So that's my first from step 1. I have step 2 being my 0, comma constant, which is negative 16. And my last step was finding my roots. My roots was 4 and 2. So I have a parabola here. So if I graph it, terrible, I get this upside down parabola. If you look in your book, it's a lot better. But it shows you what your parabolas look like and how it's facing downward. The last step, it is an inequality. That means you shade above or below. If it's greater than, you shade above. So in reality, we're shading this whole region. I'm not going to shade all of it. We're shading everything above that parabola, above the outside of that parabola, not the inside. Inequalities just simply means that the answer is between a certain range, and that range is anything outside of the parabola. Example 2. So here is where I recommend you look at your book. They talk about solving for these inequalities. There's several ways we can solve for it, and this is one of the ways. If we look at this seriously, we don't focus on moving anything out. If we look at this as being each separate equations, if we look at this as being y is equal to x squared minus 3x minus 7, and we look at this as being y is equal to 3, so it's two separate equations. We go ahead and we graph each of them. You have the graphing app, so go ahead and graph those two. If you noticed, you have something that hits in there. I have it here, just so this one will fall apart. Oh no! I'll show you once it loads. Save, recover. Perfect. I have here, nope, that's my second one. All right, I'll just do it for the second one because it only has the second one. If you look at the first one, you'll notice on your book, it has a certain graph, and it's a parabola, and y equals 3, it's a horizontal line. It hits across at this point right here. Keep in mind, it's an inequality, so less than or equal to, that means you're shading below or you're shading inside the parabola. So you're going to shade in this region right here. If you also look at the graph, and if you look at it more clearly, if I had the app up, I only have the second one up there. But if you look at it more clearly, if you noticed here on the book, it hits it at two certain locations. It hits here at -5. It hits at this location here at +4. So when we solve for it, we get this graph being between -5 and +4. Remember that it's being shaded in between. That means x could be anything in between, but we're focusing on these two lines. So that means x could be anywhere between -5 and +4. So then you have this inequalities. Parabolas, when you're solving for it, you're getting the compound inequality. Remember the and inequality and the or inequality. This is considered the and inequality. Next one is this one. X squared plus 10x plus 22 is greater than 6. This is y is equal to x squared plus 10x plus 22. And this is equal to y equals 6. I do have this one. I didn't load the second one. But if you noticed here, I have the two graphs filled out for you. That's terrible. Bloop, bloop. Oh, my word. Don't worry about it. Well, if you look in your book, it shows you where that line hits at the parabola at two locations. And also, it's greater than, whenever you're shading anything that's greater than, it's shading on the outside. That means x's could be anywhere on the outside of the parabola except between the parabola. So the 2 points that the line intersects the parabola is at, I think it was -8, -8, and this is -2. So let's say this is the y-axis line, this is the x-axis line. So it hits it at two locations, but x can be anywhere on the outside of the parabola. So again, you can use GeoGebra on your computer. It will actually show a lot better. I wish you could see what I'm seeing. It shows you perfectly. It hits at two locations right there at the two lines that I created. So now x is between x could be between -8 or anything less than -8. Or x could be -2 or anything greater than -2. So it can't be anything in between, because when we're shading, it's shading everything on the outside regions, the outside of the parabola, so that's why you have something that looks like that. The last step is solving it algebraically. Solving it algebraically means that you can solve for it by just focusing on these two things. So I have my equation, x squared plus x is greater than 20. I'm gonna move it over. I have x squared plus x equals 20. I'm going to move the 20 over to set it equal to 0. I go ahead and factor the roots. I have -5 and 4. That means the graph hits at -5 and 4. Now, for this, I'm going to go ahead and apply two different methods. It's the and method and the or method, meaning x is less than the smaller number. In this case, the smaller number is -5. So x is less than -5, or x is greater than the larger number. The larger number in this case was +4, meaning you're choosing an x value and you're testing it out to see if it actually works. So a number less than -5 and greater than 4, let's see what I chose. I chose negative 6. So x is greater than, or x is less than negative 6, I can use that. So I can use any number from the ranges of less than negative 5 and greater than 4. There's tons of numbers you can choose. Now, this number that I'm using, this test value, I'm going to go ahead and apply it with the original equation. The x squared plus x equals 20. Actually, I'm going to use the inequality sign with it so I can focus and see if it actually works out. Now, I go ahead and plug it in. So x is now negative 6, greater than 20. So I have that. I go ahead and simplify even more. So 36 minus 6 is greater than 20. And I get 30 is greater than 20. This statement works, so that means this could be the equation that we can use. Let's go ahead and apply it to the other one. So x is between the smaller number and the larger number. So remember, the arrows are always facing the same direction. There's no line underneath, so I'm going to keep it like that. The arrows always face that direction. And it's between the smaller and the larger one. Now I'm going to use a test value between the two. So a number between the two, I'm going to choose 1, because that's very easy. I think that's what I chose. Yeah, I chose 1. So now, I go ahead and plug it into the original equation. So x squared plus x is greater than 20. That means 1 squared plus 1 is greater than 20. That's going to give me 2 greater than 20. This does not work out. So the answer for this equation is that inequality. X is less than negative 5 or x is greater than 4. Let's do the next one. X squared minus 3x minus 18 is less than or equal to 0. So instead of graphing it, we can do it algebraically. Meaning, go ahead and factor, find the roots. I found my roots. I get x is equal to 6 and x is equal to negative 3. You apply 2 of the compound inequalities. So x is less than the small number, which is negative 3, or x is greater than the larger number. This is one inequality. It's one compound inequality. The second one is the and inequality, meaning x is between a certain set of numbers. So x is between the smaller number and the larger number. Arrows are always facing the same direction, and I have to include that line underneath it for all 4 of them, because this one has a line underneath it. Now let's see which one it's going to apply for. I choose a value less than negative 3 or greater than 6, and I chose the same one. X is equal to negative 6. Then we go ahead and apply it from the original equation. So x squared minus 3x minus 18 is less than or equal to 0. Now we plug in what x is. We're going to choose negative 6. And then we go ahead and solve. This is 36 plus 18 minus 18 should be less than or equal to 0. I get 36 is less than or equal to 0. In this case, it does not work out. So let's go ahead and look at this one. So a number between negative 3 and 6, I chose the easiest one. I chose 1. So we use the same equation, x squared minus 3x minus 18 is less than or equal to 0. I chose my test value being 1. I go ahead and plug it in. Then I go ahead and solve for it. 1 squared minus 3 minus 18 less than or equal to 0. And I get negative 20 is less than or equal to 0. And this statement works. So my answer is x is between negative 3 and negative 3 and positive 6. Last one is solved by graphing. We're actually going to graph step by step. We have 2 inequalities. So just like the systems of equations, this is systems of inequalities. All right there, I'll just leave it like that. Here, they want us to solve, and then they want us to name one point on that solution area and one point that's not on that solution area. So you have to graph it to see what points that you will use. So first thing, we're going to go ahead and graph. So y is less than x squared plus 2x minus 1. We graph it from the beginning. Find a vertex. X is equal to negative b, which is 2, over 2 times a, which is 1. So we get x is over negative 2 over 2. X is equal to negative 1. Next thing we do, we solve for it so we can get our vertex point. So we get y is equal to negative 1 squared plus 2 times negative 1 minus 1. So using this equation, plug it in for negative 1. If it's negative 1, put the parentheses over it. I get 1 minus 2 minus 1. And then I have y being equal to negative 1. And then my vertex is negative 1 comma negative, actually this is negative 2. -1, comma, -2. If I graph it from here, -1's here, -2 is down here. This is my vertex. Second step, we find our roots. So 0, comma, c. C is our constant. Our constant is -1, so 0, comma, -1. That means that graph is going to hit the y-axis at 0, comma, -1 right here. Third step is you can't really find your roots because I tried graphing this, or I try factoring this. You can't factor it. So the other way to graph parabolas, excuse me, is to choose one point. This is considered, I'm not going to really draw it, but this is considered the axis of symmetry. I'm going to choose one point on the x-axis to the left or one point to the right. So I'm going to choose one point to the left of it. Since this is -1, this is -2, I'm going to choose x being equal to -2, and I'm going to solve for y. So I have y, I'm going to set it equal to y. So y is equal to x squared plus 2x minus 1. I'm going to go ahead and plug in -2 in place of this equation here for x, plus 2 times -2 minus 1. So -2 in place of the x equation there. The reason why we're doing this, we're trying to find one other point to graph the parabola. So now, y is equal to -2 squared, which is 4 minus 1, and y is equal to 4 minus 4, let me see if I did this right. 4 minus 4 is 1, so this gives me -1. So I end up with a point of -2, comma, -1. So -2, comma, -1, and that is my other point that I have. So when I graph it, it's not going to be as equal. You can choose more values, so you can use -3, you can use 3, 4, 5, you can choose anything from the left side or the right side. It just shows you the parabola a lot more. That's the third step. I have one extra set of coordinates. And now I go ahead and, all right, so you shade above the line. So when you're shading above the line, this parabola, it's not upside down, but you're going to shade above the parabola line. And that's actually going to be this little area right here. Next step is y is less than 2x plus 3. If you look at it, it's y is equal to 2x plus 3. This is an equation of a line. So first thing to do to graph a line is look at the y-intercept plus 3. That's your first point. This is considered your slope, 2/1. It's positive, so your line is facing upward. So I'm going to go up to 1, 2. I'm going to go 1 to the right here, and I have a line. There's no line underneath it, so it's dotted. I get this. And less than, meaning you're shading below the line. So you're going to shade this region down here. And they have a certain region that is similar. And it's this region right here. I can draw it in blue. This region all right here is what they have in common. So now the last part of the equation is you have to name one point on that graph and one point that's not on that graph. So one point that is in the solution is 0, 3, 0, 2. So 0, 2 is between the solution. We have -1, 0. We have 1, 4. You have a lot of different solutions that you can use. So this is on it. And then a coordinate that's not on the graph is, you can choose anything from the outside here. So anything now where the blue is considered a point that's not on that solution graph. So I'm going to choose 3, 0. The one I have written down is 2, -1. So 2, -2. So right here, 2, -2 wouldn't be on it. -4, 0, -4. This number here, anything that's not on the outside, you can choose any point whatsoever. So when you graph it, you can see a lot clearer. And that's what I'll have. I'll have the graph there. And if your point's not on it, it's wrong. If you need any more help, let me know. I only have time for this many examples. I miss you guys. You guys have a good day.